This is a demonstration of how to use HD Targets by Soterix Medical. HD Targets is a simple but powerful program that allows you to achieve neurotargeting with your Soterix Medical high-definition stimulator. Neurotargeting is not like neuronavigation. Neurotargeting allows you to identify a brain region, set stimulation constraints like how many electrodes you have available, and then automatically optimize your HD montage to stimulate that region. Let's go through one example. Before you begin, note that the interface has three sections: the control panel on the left, the help section on the right, results are displayed in the middle. The help section and control panel can be minimized and the entire application resized as needed. Step 1. Your HD targets will come preloaded with one or more head models. In this case, basic HD targets comes loaded with one adult male head and one standard, or the MNI 152 head. Additional head models available include more adult male heads, adult female heads, pediatric heads, and also heads with lesion, for example, after stroke. Let's select standard head and the default 93 electrode density option. Once a head is selected, the different segmentation masks can be viewed in the middle. You can zoom, move, change, and rotate views using the keyboard and the mouse. See the help section on the right for specific instructions. Step 2. In the second step, you first select your desired target in the brain. Hit the search button to launch a new window to search for available targets. You have 1,105 target locations to choose from. You can either search by index number on the top left, or by entering a keyword on the top right. For instance, entering keyword hippocampus results in 6 hits. Or you can search by Brahman area, for example, 25. Select the region you are interested in and hit OK. Let's select region 281. Note that the target location selected is automatically entered in the target location box. Next, select your constraints starting with the number of current sources. This is determined by the HD stimulator that you have. If you have the MXN stimulator with 8 channels, select 8 channels. Next, select field orientation. For example, select radial in if your target is superficial, since pyramidal neurons are predominantly oriented normal to the surface. Lastly, select your optimization criteria. You may choose to select maximum intensity, which delivers the maximum electric field to the desired brain target with limitation of 2 mA total applied current, or you may select maximum focality, which delivers the maximum current intensity to the target while sparing the remaining brain regions. Let's select maximum focality. Soterix Medical HD Targets automatically calculates the most optimal electrode montage based on the criteria you indicated. This is illustrated by the 2D electrode layout in the middle and by the optimized montage table on the left. For each electrode indicated, the current you need to apply to that electrode is indicated in the false color map. For example, electrode at location CZ will need to deliver negative 0.95 milliamps, while electrode at location FP1 will need to deliver positive 0.76 milliamps. If you selected 8 electrodes are used in total. To visualize where each selected electrode is located in relation to the underlying brain, you can click on the location in the 2D electrode layout and observe the corresponding 3D electrode layout. The selected electrode will be displayed in red, while the others stay green. Now, let's say you're interested in the maximum intensity prediction. Observe how HD targets will instantaneously update to provide the most optimal electrode montage. In this case, the prediction is bipolar with anode at FP1 and cathode at P2. Let's go back to maximum focality. Step 3. To show how current flows through the brain, next hit View Optimal Current Flow. Soterix Medical HD Targets will now show you the current flow pattern through the head in both 2D and 3D for the optimized electrode montage. The default view in 2D shows the current flow for 3 different views in false color, with 0 indicating no current and red indicating maximum current with the electric field intensity indicated. You can select to view the subject's MRI. You can also toggle the current direction vector and toggle the electric field, or view altogether. The selected field intensity value in the control panel shows the field intensity inside the open white circle at the target location. An electric field of 0.227 is induced at the desired target. You can navigate through the head by simply clicking around in the 3D space or move slice by slice at 1mm resolution by using sliders in the control panel. The selected field intensity value will constantly update, always showing the field intensity inside the open white circle. You can use this feature to determine the field at any voxel in the head. If you are interested in again visualizing the target and the induced current flow, simply hit Show Targets. The field intensity scale can also be adjusted as needed, using the buttons at the top and the bottom of the bar to better depict current flow patterns. Note that the optimized electrode placement is still shown in the bottom and the chosen target region, 281, and the chosen constraints are listed for reference. To view predictions for the same target but with maximum intensity constraint, hit Select Targets, select Maximum Intensity Constraint, and hit Step 3, View Optimal Current Flow as before. Note, an electric field value of 0.344 volts per meter is induced at the desired target. This shows that the maximum intensity constraint induced more current flow in the target but will also lead to more current flow in other regions. To explore the current flow in 3D, just click the 3D option in the control panel. The model can be rendered either as a solid surface or a transparent surface. The solid surface is the default view. You can zoom, change views, rotate, move the 3D view as before using your mouse and keyboard. By clicking Display Cutting Plane, a plane will be shown in the rendering. The X and Y value as well as the distance from the center of the plane can be adjusted using the sliders to define a precise location. To cut the 3D volume at the plane and explore current flow inside the head, simply click Cut, and the head will be cut at that plane. If you want to undo the cut, just click Undo Cut. By selecting Cut by Target, the plane will cut the head volume at the location of chosen target in Step 2. The white sphere will show the location while the arrows show the selected field orientation. The field intensity scale can also be adjusted here in the same way as a 2D view. Now let's take a look at the transparent surface rendering. As you can see, The opacity function section allows you to set the opacity of 4 different electric field ranges, independently of one another. The ranges are determined by splitting the maximum electric field intensity value on the color bar into 4 divisions. For example, for viewing the volume of the brain where the top 25% of maximum electric field intensity is induced, you would set the opacity to 1 in the last range, while setting opacity to 0 in the other 3 ranges. You can then make the lowest 25% semi-transparent to better appreciate the extent of the maximum 25% electric field distribution. The target and desired orientation is shown at all times. If at any point you want to save what you are viewing, click on the camera icon and save your image. If you want a higher resolution image, you can increase the resolution up to 6 before saving the image. If you want to explore optimization for different targets, just repeat these steps. HD Targets, another innovation only from Soterix Medical. HD Targets is optimized to work with the Soterix Medical family of HD, tES, and tES stimulators. For more information, visit us at soterixmedical.com.